Today we will discuss replication in distributed system. So first, what is replication? Replication means data duplication or creating multiple copies of same data. So let's suppose we have a database and the data, and for replication we need more databases. So we have created database server 1, database server 2 and database server 3, and then we copy the data to other databases. That is replication. Now, what is the need of replication? So first, to handle the failure and maintenance. Second, to handle the scale. Third, for geographic reach. So what is database failure and maintenance? So let's suppose this is a client and this client is making the request to this database. After some time, due to some network issue or database issue, this client is not able to connect with this database. Now we don't have anything to serve this client request. So to handle this failure, we can create multiple databases. We have created 3 databases and client can connect to any available database. With this replication, we can handle the database failure. Same way we can handle the database maintenance or upgradation activity. So let's suppose upgradation or maintenance activity is ongoing on database 3. Still we have a database 1 that can handle the client request. Second is the scale. So let's suppose in the same example, client is making the request to this database and this database can handle only 100 requests per second. Because we are using only one database and this system can handle only 100 requests per second. To handle more requests, we need more databases. Let's suppose we have created 3 more databases and each database can handle 100 requests per second and client can connect to any database. We are using 3 databases in this system and this system can handle 300 requests per second. Next is the geographic reach. So let's suppose we have a 3 client in 3 different regions and we have only one database only in the Asia region. So each client is connecting to this Asia region database. Now the problem with this approach is the request coming from the different region will take more time as compared to request coming from the local region. So here red request is coming from the different region and green request is coming from the local region. So red request will take more time as compared to green request. So to solve this problem, we can create database in each region. So we have created 3 database in each region. So North database can handle the North request, Asia database can handle the Asia request, and same for the Europe. What are the types of replication? So first is the synchronous, second is the asynchronous. So let's suppose we have a databases. One is database 1, second is the database 2. And client is making the write request to database 1. Write request is the setting the value of x equal to 1. In the synchronous, before going to the client, we first replicate the data to all the replicas. So here we have only one replica database 2. So database 1 replicating the data to the database 2 and waiting for the successful response of the database 2. After getting the response from the database 2, then database 1 will persist the data in their local storage and successfully responded back to the client. Now the advantage of the synchronous system is the consistency. Let's suppose the same client coming back to the database 2 and making a read request to get the value of x. Database 2 already have the updated value of the x, then database 2 will respond back with the updated value of the x. The problem with the synchronous system is the high latency. For every write request, we are waiting for the acknowledgement of the replicas. Here database 1 is waiting for the database 2 response. So that is adding more latency. For every write request, we are serving on high latency. Second problem is the no resiliency. So let's suppose in the same example, client is making the write request and due to some reason database 1 not able to connect or not able to replicate the data on database 2. Because we could not replicate the data, so we need to fail this request. We are sending the failure response to this client. From the client point of view, we are very less available for writing the request. Second type is the asynchronous. So in the asynchronous, we will use the same example where client is making the write request to the database 1. In this, after persisting the value in the local storage of database 1, we will successfully responded back to the client, and the syncing part is happening in the background. That is not directly depend upon the main write request. So because both these flows are asynchronous, so this main flow is happening on different thread and this syncing part is happening on the different thread. Now the advantage of this asynchronous system is the low latency. Because this syncing part is happening on the different thread that is not part of this write request, we can serve write request on very low latency. Second is the resiliency. So in same example, client is making the write request. Because we are not dependent on the syncing part, after persisting the value in the database 1 local storage, we can respond back to the client successfully. And if anything failed in the syncing part, that will recover after some time, and that is not directly impacting the our main write request. So from resiliency point of view, we are more available for the client, or we are highly available for the clients. Now issue with the asynchronous system is the inconsistency. So let's suppose in the same example where we could not sync the write request to the database 2, and now the client is coming back, same client is coming back and making a write request to the database 2 and getting the value of x. Because we could not sync the value of x in database 2, now we don't have x. That's why the database 2 responding back to the client, there is no x in the database. So from client point of view, both databases are in not in sync. So these inconsistencies are not permanent. These inconsistencies are resolved after some time. So these are eventual consistent system. So let's suppose after some time this networking issue is resolved. Now both the databases are in sync. So now we can say both the databases are eventually consistent. So as we discussed, these are the pros and cons of the synchronous and asynchronous systems. So synchronous systems are more consistent as compared to the asynchronous system, and synchronous systems having more latency as compared to the asynchronous system. In the synchronous system, the latency is also dependent upon the number of replica. More number of replica, then the latency will be more. In the asynchronous system, latency is not dependent upon the number of replica count. The synchronous systems are less resilient as compared to the asynchronous systems.